Today we'll start with concentration of a solution. Okay. Now, what is basically the concentration of a solution? Now, for example, if I tell you that and there are two beakers here with me, both of them has 100 ml of water, 100 ml of water, right? Correct? And I added in first one here 1 spoon of salt and in the other one 2 spoon of salt. Okay. So in which of the glass I will feel a more amount of salt? In the second one. Right. Why? Because I will say that the concentration of salt is more in B container as compared to A. Correct? Now, how can I say that these concentrations are different? Why? Because of the number or maybe mass of the salt or the amount of the salt. Correct? Correct. So what I have done here, I have fixed the volume of my water here and it was very easy for me to judge the concentration. But sometimes volumes are different. Let's say 500 ml of water, 2 spoons of salt, and again, let's say 2500 ml of water and 5 spoons of salt. Now, since my volume is different, so it is difficult for me to calculate whether which one is now concentrated and which one is diluted. Correct? Right? That is the reason we have concentration terms or the concentration formulas by which we are able to decide, by which we are able to calculate whether which solution is concentrated and which solution is non-concentrated. Like in medicines also, medicines are very specific. If you see the back of the medicine, you will be observe these kinds of word, weight by weight or weight by volume percentage. These kinds of things are given on the back side of the medicines because they have to be very specific in their concentrations. Okay. So as the NCERT is saying that we observe that group A and group B obtained different shades of solutions. So we understand that in a solution, the relative portion of solute and solvent can be varied, right? Amount of water and amount of salt can be varied. Depending upon the amount of solute, whether my salt was high or whether my salt was low, present in the solution, it can be called dilute or concentrated. Now, if we say in a comparative term, can we say that A in the A container, A is quite dilute as compared to B because in A there is high amount of water. Now we'll understand what the word meaning dilution. Okay, sometimes what happens, our mother or our helper cooks the food, and in that condition, sometimes maybe the food in the food she added quite it becomes quite chilly or it becomes very salty. So you will say, Mama, aaj na there is high amount of salt in the food. So what our mothers will do? Our mothers will add 1 glass or 1 bowl of water in it, and again she will boil it for once. She will give a boil, and then she will serve you. And now you will say it is fine now, right? So what happened? She increased the amount of solvent, and now my solution is diluted. When you increase the amount solvent, man, as compared to solute, the amount of solvent is high. That solution is known as diluted solution. But if in my solution the amount of solute is comparatively very high, we call it as concentrated solution. Any confusion in these words, concentrated and dilution? Yes. So dilute and concentrated are comparative terms. As I told you, if I gave you this, it is 100 ml and 5 spoons of salt. In comparison to what you will say it is diluted or it is concentrated. If I say I have 100 ml of a solution where I have 2 spoons of salt in it, then in that case you will say yes, this one is concentrated and this one is diluted. Clear? So these both terms are comparative terms. Now we have one activity where they are saying that take approximately 50 ml of water, each in two separate beakers, like I am doing right now. I am taking 100 ml. Let's take that activity, and they are saying 50 ml of water. 50 ml, 50 ml of water I have. They are saying after that add salt in one beaker and add sugar in one beaker. So in this one I have salt and in this one I have sugar. Okay. With continuous stirring so that it will become a homogeneous mixture. With no more solute can be added, heat the content of the beaker to raise the temperature by 5 degrees Celsius and start adding the solute again. Now, what is actually happening when these homogeneous mixtures are mixing? So, what is happening? We know that uh, when the sugar and the salt are diluted or mixed in a solution, in a water solution, what is happening? Let's say these are the molecules of water in my solution. It is just now water only. Okay. So as soon as possible, I added some amount of salt to it. So my salt will be dissolved in the between places of the, or we can say the intramolecular space of the water. Okay, my salt will be take its space in the intramolecular spaces, salt or sugar. Okay, so let's say what happened, I added 1 spoon, so some of the spaces were covered, no problem. Now I added 2 spoons. Some more spaces were covered. I added 3 spoons. Some more spaces were covered, right? I added 5 spoons. More space was covered. 6 spoons. More space covered. 7 spoons. Again, more space covered. A time will come that all the free space is completely occupied by the salt or sugar. Now, if I added 10th spoon, what will happen? Correct. My solute will now settle down. It won't be dissolved. It won't be dissolved anymore. And that state of a solution where my solute can't be dissolved anymore is known as saturated state. Saturated state. Okay? Where my salt cannot be further dissolved in salt or sugar cannot be further dissolved in the solution is known as saturated state. Okay. Now, in the other part of the activity, what I did, I applied some amount of heat to it. Okay. I applied some amount of heat to it. Now, when I am providing temperature, what will happen? There will be a chaos, means the molecules will be running here and there, here and there, here and there, correct? By attaining the energy from the temperature, the molecules will be moving here and there, here and there, and here and there, resulting a little amount of interspace will be increased. Okay? A little amount of space will be increased now because the molecules have moved a lot and a little amount of space is now free, right? So now in that hot water, if I added more sugar or salt, or let's say my solute, now more salt can be dissolved at high temperature. Okay. So as the temperature increases, you will be able to add more salt or more sugar. So we can say by increasing the temperature, by increasing the temperature, you increases the saturation point, right? Earlier, my saturation point was, let's say, 10 grams of salt, but as soon as I increase the temperature, I was able to add 5 more grams of salt. So it increased from 10 to 15 grams, correct? Clear? Okay. So is the amount of sugar or salt or barium chloride is BaCl2, that can be dissolved in water at a given temperature the same? No, now more amount of salt can be added. Okay, so at any point and any particular temperature, a solution that has dissolved as much solute as it is capable of dissolving, it is said to be saturated solution. Now, I believe that you understand the meaning of saturated solution. Means the limit is completed. All the intraspace, all the intraparticle spaces, the space between a particle is completely occupied by the particle, and my solution is completely saturated, right? Also, we can say when no more solute can be dissolved in a solution at a given temperature, it is called saturated solution. Now, the amount of solute present in the saturated solution is called solubility. So, can I say with increase in temperature or by increasing temperature, by increasing temperature, solubility is also increased, right? Solubility is also increased. Also, I can say that temperature is directly proportional to solubility. Means if my water is cold, my solubility will be less. That means my temperature is less. If my water is cold, that means my temperature is less also, which means my solubility is also less. Correct? My solubility is also less. If the water is hot, that means the temperature is more or temperature is high. Then in that case, my solubility is also high. Clear? My solubility is also high. Chalo. Now, where were we? If the amount of solute contained in a solution less than the saturated solution, that is known as unsaturated solution. Like for example, when I was adding 3 spoons, 2 spoons of salt, 5 spoons of salt, up till 7 spoon or 8 spoon, it was a unsaturated solution. Means there are spaces left. More salt or more solute is will be dissolved. It is capable of dissolving more solute. What would happen if we were to take a saturated solution at a certain temperature and cool it slowly? It happens when our mothers or our guardians make when our guardians make what? Sweets. Okay. So at very high temperature, when they are mixing sugar in it, it will be in the soluble form, right? It will be liquid when it is in that kadhai. So it will be very in a liquid form. But when it is left to settle down, to cool down, it becomes solid, right? We say barfi, right? Why? Because in that case, what happens? When we increase the temperature, the molecules were quite far away, no problem. So we say sugar got settled between the spaces, right? But when we decrease the temperature, when we allow the temperature to cool down, to come to the room temperature, or even we keep it in the freezers also to cool it down quickly, the the molecules of water will now come more closer. Because of that, the space will be less and the sugar will be now the some amount of sugar will be undissolved, right? Which will help to make that solution now solid. Okay, and we eat that as sweets. Now that solid form of sugar gives the shape to that solution because now it is solidified and we are able to eat that sweet. Okay, that is what I'm saying. The undissolved sugar will come out or get undissolved. It will solidify because at room temperature, if you see in your sugar boxes, it is solid form, right? So one that got dissolved is dissolved, but the one that did wasn't able to get dissolved at lower temperature, it will now solidify as it is as the room temperature in those forms of crystal, right? And that will give the solid shape of our sweets, right? It becomes solid. Why? Because of that sugar only. Because water is what? Water is in liquid form at room temperature. So how our burfis are in some particular triangular shape or square shape? Because of that sugar. That sugar is giving it that shape, that solidarity. Clear? So we can infer from the above activity that different substances in a given solvent have different solubilities at the same temperature. The concentration of a solute is the amount of mass or volume. Now, this is your definition for the concentration, that what is the amount of the solute per unit mass or per unit volume. Okay, clear? Okay. So there are various ways of expressing the concentration of the solution. First way is by expressing it by mass percentage. So mass by mass means mass of the solute and mass of the, when you are comparing mass of the solute and mass of the solution on the basis of percentage. Like if I say in 250 grams of water, I added 50 grams of salt, right? So in 250 grams of water, I added 50 grams of salt. So this is what? Mass of my solvent and mass of my solute, right? So again, if I wanted to make my concentration term or know the my concentration of salt, what will I do? Mass of solute, that is in this case 50 grams, and what will be my mass of solution? Very good. My mass of solution will be mass of solvent plus mass of solute. In some questions, directly the mass of solution is given. Some questions, mass of solvent and solute is given. So when it is given in the form of solvent and solute, you have to add them both. So it will be 50 into upon 300. And now we have to know the mass percentage of the salt. So when we wanted to get the percentage, you multiply it by 100. So if I wanted to know the mass percentage of salt in water, it is 50 by 300 into 100. That gives us 50 by 3, right? Now if we divide 50 by 3, what we'll get? That is 16.66%. 16.66%, right? So if I wanted to expand this information, how can I expand this information? That in 100 grams of solution, right? 16.66 grams is salt. Correct? In From this 16.66 concentration term, I can get that in 100 grams of solution, because we took out the percentage of the solution with the 100. So in 100 grams of solution, 16.66 is salt. And how much amount of water will be there? Correct. 100 minus 16.66 will be my amount of water. That will be 18.34 grams of water will be there. Understood mass percentage? Mass by mass percentage of solution. Now, similarly, we'll come to mass by volume percentage of the solution. Okay. So in the mass by volume percentage of the solution, mass by volume percentage. So here again, mass of solute and volume of solution. Okay. So again, let's say 250 grams of salt. Let's say sugar now. Let's take sugar now. Sugar and 1000 ml of solution I have. So my mass by volume percentage will be 250 upon 1000 into 100. Correct? So again, two zeros cut, 1010 cut, that is 225 grams, or right, or 25% of the solution, 25% of the mass by volume percentage of the solution. Again, if I wanted to express it, how will I say that in 100 ml of solution, 25 grams of sugar is present. Correct? I won't say 1000 ml because I have calculated with 100. It is a percentage form. So whenever we take it to the percentage, so we calculate it with 100. The total amount is 100. Okay. So 100 ml of solution contains 25 grams of sugar. Clear? I hope mass by mass percentage and mass by volume percentage is clear to you all. Okay. Last one is there. Last one is volume by volume. So here again, volume of solute, volume by volume percentage. So volume of solute and volume of solution. Clear? So 250 ml of water, 250 ml of sugar in, let's say now make cold drink. Okay, so 250 ml of syrup, that cold drink syrup, in 1000 ml of water, or in 1000 ml of solution. Okay, so now we'll do what? 250 upon 1000 into 100. Again, two zeros cut, 10 cut, 25%, which says that 25 ml of syrup in 100 ml of solution, right? Okay. So now we'll do a practice numerical regarding the question, and then we'll move forward. Okay. Let me write the question for you. Question for you is that a solution contains 30 gram of sugar. A solution contains 30 gram of sugar dissolved in 370 grams of water. Dissolved in 370 grams of water. We have to calculate the concentration of this solution. We have to calculate the concentration of this solution in terms of mass percentage, in terms of mass percentage of solute. For us, that is sugar. Full stop. This is the question for you. So, we have mass of solute, that is 30 grams, and mass of water, that is 370. So, my mass of solution will be 400, right? 400 grams into 100. That will be my mass by mass percentage. So again, two zeros, 30 by 4, which will give me 7.5 percentage. What is the interpretation? That the concentration of this solution is 7.5%, right? Or it is 7.5% sugar solution. Or I can say that when or if I have 100 grams of solution, then it contains 7.5 grams of sugar in it. Correct? Now, one more question for you. Okay, so the other question is, if 110 grams of copper sulfate Copper sulfate is a blue color powder. When dissolved in water, it gives a sky bluish color solution. Copper sulfate written as CuSO4. 110 grams of copper sulfate is present in 550 grams of solution. Calculate the concentration of the solution. Calculate the concentration of the solution. Yes. Now we are 20% correct. That is again mass of solute, that will be 110, and mass of solution 550 into 100, 0 cut, 11 upon 55 into 100, that will give you 20%, right? 1 by 5, it is 100 by 5, 20. That is 20%. Again, if I want to interpret this, what does it say? That if I have 100 gram of solution, in that 20 gram will be copper sulfate. Last question for today. That is, a solution contains 50 ml of alcohol. 50 ml of alcohol mixed with 150 ml of water. So we have to calculate the concentration of this solution in terms of volume percentage of solute. volume percentage of solute, that is alcohol for us in this case. Try this one. If we say here volume of solute, that is 50, and volume of solution is, that is alcohol plus water, that is 50 plus 150 into 100. So 50 upon 200 into 100, 50 by 2, that is 25. So we can say that if I have 100 ml of solution of alcohol and water, in that 25 ml will be my alcohol and 75 ml will be the water. So this was about the concentration of the solution. Do you have any doubt in the concentration of the solution? Any doubt in the concentration of the solution? It is clear? Okay. Now I wanted to make you a chart regarding the solutions, so that if it is comes in the comparative study, you are easily able to differentiate between the charts, and you are easily able to make the comparison or do the comparison. Okay. Okay. So here for first we will be writing the property. Here I will be writing the property. Then are three solutions, that is true solution, then suspension, and then colloidal solution. Okay, so my first property here will be types of mixture. Types of mixture. So in true solution, the type of mixture it is correct, homogeneous mixture. In saturated, it is heterogeneous, and in colloidal, heterogeneous. Then second point will be particle size. So in true solution, the particle size is very small, right? That's why it is not able to scatter the light and we are not able to see the beam of light. Whereas in the suspension solution, the particle size is very large. Correct? And in the colloidal solution, the particle size is moderate. Moderate means between the very small and very large, somewhere in the middle. Then third is Tyndall effect. Tyndall effect. So in true solution, there is no Tyndall effect, whereas in suspension solution, it is yes, and in colloidal solution, it is yes. But there is one situation for suspension, that if kept undisturbed, the particles will settle down, right? If it is kept undisturbed, then what will happen? The particles will settle down, or will sediment, we can say, settle down, and then it won't be showing. So no in that case. Then it won't be show, because the large particles aren't there to show the Tyndall effect. So in that case, it won't be showing me any kind of Tyndall effect. Then coming to next, that is stability. So true solution is very much stable. Yes, if we kept it somewhere in the corner, it won't be like that. The particles are settling down. But in the case of suspension, they are not stable. If kept undisturbed, the particles will settle down. Same with the colloidal solution, they are also very stable. Right? Then visibility with naked eyes of particles. Visibility with naked eyes. So are you able to see the particles of true solution? No, right? But you are able to see the sand particles, correct? That means we are able to see the particles with naked eyes. And again, in the colloidal solution, we won't be able to see the particle size because it is moderate size. Then the sixth one is your separation by physical methods. So as I told you, sieving, जो छलनी से हम छानते हैं, sieving. So by sieving, can I separate two mixtures of two solution? For suppose I mixed salt and water, right? And I take a sieve. Now will they will be different, like the salt will be captured in the sieve or not? No. So separation by physical method? No. But if I have soil particles in it, if I sieve it, will I be able to filter it? Will I be able to separate both of them? So yes, by filtration. And what about the colloidal solution? Again, no, I won't be able to filter them. Okay. So this was about the solutions and the concentration terms in the solutions. Any problem in this topic? Okay, great. We discussed about dispersed phase and dispersed medium, right? So in a colloidal solution, what is the dispersed phase? Dispersed phase? Correct. Now we have types of changes, that is physical changes and chemical changes in front of you. So what are physical changes and what are chemical changes? You tell me. So physical changes and chemical changes, as you said that very rightly, that physical changes are those changes, if we say, where the chemical component, or we can say the chemical properties of that particular substance, the substance is not changing its identity. Whereas in chemical change, the substance is changing its identity. Like for example, if I take a paper and I tear it, so it is a change where its size is changed, right? The size of the paper is changed, but the it is also the same paper and it is also the same paper, like it's the same component of the paper. Nothing is changed. The chemical composition, the chemical properties of both will be same. But if I burn this page, now what will happen? The properties of the burned page will be different to the page that is not burned. When it is burning, it is changing itself into carbon dioxide. The particles are changing. It is changing into that carbon soot, that black color soot, and some amount of moisture is also released. So the paper has changed itself into three different components, that is carbon dioxide, carbon soot, and your water in the form of moisture, right? Understood? So these changes are permanent, we say. Like for example, one more example for you. We have a candle here. Okay. Now in a candle, what is happening if I am burning it? So the candle near it will it shows that black soot, no, black color of deposition is present there. Why? Because the candle which is burning, it is again forming what? Carbon soot, that black color soot or carbon, we say. Carbon dioxide gas is released due to burning, and again moisture is released, right? Carbon of the wax is releasing. whereas the melting is also happening. So two phenomena are happening here, burning as well as melting. Correct? So burning here is a chemical change, whereas melting here is a physical change, because that melted candle we can use it again, and then we can again form that shape and we can add the wick in it. This thread is known as wick. We can add wick in it and then again we can use it for burning, right? So burning of a candle is a chemical change, whereas melting of the candle, the melted candle is nothing else. It is just that same wax. Once it will get solidified, it will be same as that of the previous type of candle, as it was earlier. So it is a physical change. Clear? Okay. So in the previous chapter, we have learnt about few physical properties of matter, the properties that can be observed and specified like color, hardness, rigidity, fluidity, density, melting point, boiling point, etc. are the physical properties, right? The interconversion of state from solid to liquid to gas, or from gas to liquid to solid, changes because of these changes occurs without change in the composition, like ice is also water, then liquid form of water is also water, and the steam form of water is also water. Only the physical state is changing. That's why we say it is a physical change. The chemical H2O is still H2O in all three forms, right? As they have given, although ice, water, and water vapors look different in their state, but their chemical properties, chemical composition is same. Both water and cooking oil are liquid, but their chemical characteristics are different. Cooking oil has different chemical composition, whereas water has different chemical composition. Their inflammability property is different, their smell is different. One causes burns, whereas the water extinguishes the fire. Again, difference in their properties. It is the chemical properties that is known as inflammability. Okay, so inflammability is a chemical property here. Whether it catches fire, it can cause fire or not. Burning is a chemical change. During this process, one substance reacts with another and undergoes some chemical composition. I've given you an example that the candle, the wax has changed itself into carbon dioxide, and water. So it has completely changed its properties, right? Undergo changes of chemical composition. Chemical change brings change in the chemical properties of matter and we get new substances. A chemical change is also called chemical reaction. Some kind of chemical reaction is occurring there, whereas some chemical change is occurring. Now, during the burning of candle, as I just explained you, both chemical and physical changes occurs. Okay? Okay. So this was it regarding today's lecture. We'll start what are the types of pure substances. In this, we'll understand about elements and compounds and many other things. Okay, we'll start that in our next lecture. So students, I really hope you like this session. If you have any doubt, you can definitely ask me in the comment section. I also have a Telegram channel and I will add link for that in the description box. Also, in the Telegram channel, I add all the required PDFs, all the required notes, and so you can check it out there also. Regarding the syllabus, please do like, share, subscribe, comment, and also hit the bell icons for the regular updates. Have a nice day. Thank you.